Okay, so this is a demonstration of a bunch of really simple Rebol examples. We've got 9 little applications here taken from the short examples at re-rebol.com. You can get there by clicking on Rebol Forum at the very top left link, the short code examples. I just took some of the very first ones. I'm going to explain how the code works, kind of give you an idea of what you can do with just a very small amount of code in Rebol. So the very first one is a sliding tile game, and what this does is it starts a layout. We create a user interface in Rebol with the words view layout, and everything inside this square bracket block is included in the user interface. The very first thing we're doing is a very powerful part of the built-in vid dialect, which we use to create interfaces, is we create a new style, a new type of widget, which is derived from the built-in box widget, and that is going to be red. Whenever one of those T widgets is clicked, we're going to do this bit of code. We're going to save the current offset, or the current position of the box, in the variable x, create a variable or a word in Rebol using the colon symbol, and then we're going to set the offset of the box to wherever this E box is. That's sort of just an empty placeholder box. And then we're going to set the E offset, the E position, to where the box originally was. So this basically swaps the positions of the current box, of the clicked box, and this empty E box down here. And then on the screen we're going to add a whole bunch of those T styles, those T boxes, with the numbers 8, 7, 6, 5, 4, 3, 2, 1, and we're placing these across the screen, and whenever we see a return, that basically moves the next set of things in the user interface down to the next line in the user interface. It's kind of like pressing return on a keyboard, but in the graphic interface. Okay, so that's all we need, and I'll go through all these at the end, show you how they run. So 2 lines of code, and we get an actual sliding tile game, and we could add some more. You'll see in the other examples I've got up there, you could add some evaluations here to check and see if the boxes are next to each other the way they're supposed to be, but just for the purposes of creating a little demo example, that's enough to get the game running. Okay, so next is a little sort of CRUD app. It allows us to create and save and load and delete items from a to-do list. So it's about 5 lines of code, and again we have a view layout. Very first thing we're going to have in that layout, by default these things are placed below one another. Must be used at a crossword. So in this user interface, we don't have the crossword, so each of these things is going to be placed on top of one another. We create a text list, labeling that T, so that's a list of items displayed on the screen, and whenever an item in the text list is clicked, basically we're removing it from the text list. So we remove wherever it's found in the data in that text list. The value refers to the item that's been selected, and then we update the view. It's very simple. Any item that's clicked on will be removed. And we could add some conditional evaluation here, ask the user if we really want to do it, that sort of thing, but again, for the sake of the demo here, we'll keep it simple. Next we have a field widget, and Rebol widgets are called styles. Sort of a field style here. Whenever something is entered into the field, we're appending to the data in that text widget a copy of the value which has been entered, and we're showing the text widget, we're updating the display, and then we're clearing the item, we're deleting the item that was typed into the field. So user types in the field, that gets appended to the text list, and then the field is cleared. And we have a button that has the word save on it, and whenever that's clicked, we're saving to this to-do.text, whatever is in the to-do list, and alerting the user with a little message saying that it's saved. And then we have a button with the word load on it. And whenever we do that, we're setting the data in the text list to whatever is loaded from that to-do.text, and then we're updating the text list. It's a complete little CRUD app. Run that in the end. Next example is a barcode generator, bar chart generator, and we have one line of data here labeled D, and so we have for each of these months a value that's going to be converted into a little graphic display. And so we start a GUI block here, label it G, and for each of the items, for each of the 2 items in the D block, in the data block, we're labeling each of those items iteratively M and V as we go through each of these loops. Every 2 items from this block are going to be labeled M and V on each iteration. And for each of those items, we're appending to the GUI block this little bit of reduced code. So for each of those months and values, we're appending a button with the text of the month, and then we have a number here which is going to be the value times 10, and that's going to be the size of the button. So in Rebol's bid dialect, you can set the size of anything on screen just by putting the number of pixels after it. So basically we get a bunch of buttons with, like, this first button is going to have March on it, it's going to be 130 pixels, this is going to have the word April on it, it's going to be 90 pixels, and so on. So once that loop is done, we have a whole block of code that's labeled G. We just view it and see it on screen. Okay, Madlib Maker. We start here. Very first line, we create a string labeled T, and I have it included in curly braces. You can include that inside quotes if you want. Curly braces are used in Rebol to do multi-line strings, and I tend to use them in general because you can see where the strings start and end a little more easily. So I have a T word now, which represents that string of text. And next we're going to create a layout, and in that layout we've got an area which is labeled A, and which wraps automatically, and then what's going to be included in that area is that T string. And we have a button with the words make Madlib on it, and when that button is clicked, we're doing this bit of code right here. So creating a new variable called X, and that's going to contain whatever was typed into the area field, which that by default was that string of text labeled T. So this allows the user, the interface allows the user to edit that text and type in any Madlib they want, and then we assign that edited text to label X. When it's done, we undo the user interface. And then we go to a parse operation. This parse operation is going to go through that text that was under the interface, and for any place in that text, basically between pointy brackets, up to a pointy bracket and going through a ending pointing bracket, we're going to copy that value to the variable B, and then we're going to append to this new block W that word, and we're going to do that all the way to the end of the text. So what this does, this little parse evaluation, parse is fantastically powerful, but here we just need it to collect all of the things in the text which have pointy brackets. So this is going to create a block called W, which contains, in this case, and by default, the text with pointy brackets, name, thing, name, adjective, and thing. So that's what our W block contains at the end of the parse operation. Then we're going to go through a for each loop. So for each item I in the W block, and we're actually using the unique function here. What that unique function does is it basically eliminates any duplicates in the W block. So if by default the W block contains name, thing, name, adjective, and thing, the unique operation will reduce that down to just name, thing, and adjective. So for each item in that unique block, using I to refer to each item in each iteration of the loop, we're going to replace everything in the text, in that X text. Every time one of those unique items is found, one of the name, thing, or adjective is found, we're replacing that with some text entered by the user, asked from the user. And we're asking the user that bracketed text plus joined together with a colon and a space. So we get a nice little request of the user. So again, we're going through each item in those words, unique list of words, and replacing everything in the text every time in the text, or every place in the text where one of those bracketed words is found, with whatever the user types in. And so that at the end of that operation, all of those Madlib words have been replaced in the text, and we just alert that to the user. Okay, here's a calculator app. Again, we're creating a user interface. So everything in here is inside the square brackets is put in the user interface, and we start out with a field labeled F, which is 225 by 50 pixels, and a font size of 25. And again, by default, everything in user interfaces in this vid dialect is put below one another, so we use the across word here, and now everything after that is placed across the screen by default. If we want to go back to the other default way of aligning things below one another, we use the word below. I'm not going to do that here, but it's very easy to switch back and forth between laying things out horizontally and vertically. And the very first thing we do, again, is create a style. It's a really powerful part of the vid language. It lets us create new objects very simply, new widget objects. So we're creating a style called B, and what that B style is a button, which is 50 by 50 pixels. And whenever one of those buttons is clicked, what we're going to do is append to the text in the F field whatever text is on the face of the button, and then we're going to update the F field to show it. So basically, we're going to add a whole bunch of these buttons now, these B styles with the numbers 1 through 9 and all of the operators that we want, plus, minus, and so on. And that return just creates a new line. We've got a layout of those buttons, which, whenever pressed, adds the text on the button to the field above. The only one that's different here is the equal key. When that's clicked, we use the attempt function to handle any errors. So, for example, we tried to divide by 0, that would create an error that would end the program. In this case, if we wrap that whole operation in attempt, it just handles it and keeps the program from crashing. But otherwise, what we're going to do, if there's no error, we're going to set the text in the F field to this little evaluation. What's going to happen here, this do evaluates whatever text is in the F field. So if we have, for example, 63 plus 7, that would evaluate to 70, and then we turn that into a string with the form function and set the F text, the text of the F field, to that new number. So that will be then displayed in the F field. So we can keep a ongoing running set of calculations in the field. And that last thing here is just a show to update the F field. Okay, so next we have a little personal calendar, and what that's going to do is let us save events on certain dates. The very first line here, this is just a simple way to create a file if it doesn't exist. So we're going to use the write function with the append option to the append refinement to write to this file. In Rebol, files are preceded by the % symbol that represents a file data type, and what we're doing is writing an empty string here. So what this does is, if the file exists, it appends nothing to it. If the file doesn't exist, and this is the real purpose of this line, is just it creates the file with nothing in it. So that just ensures that we have a file, and if we wanted to use a different file name, we'd change that. So anytime we were creating a new file, we just make sure it exists. And then the rest of the program just runs in a forever loop. So we just keep doing this over and over and over until the user closes the program. And we can use the letter Q to end the program. It's the same thing as quit. So the first thing that happens every time in this loop is we request a date from the user. We assign that requested date to the word D, and when you run that little request interface, this little request date pops up a date requester. When you run that, if you click cancel, this returns a value of none. So the D value, if it's none, basically we quit. So that's how the user gets out of this. Just closes the date requester. Then here we're going to create another user interface, and we're going to center it on the screen. Center face centers it. And inside that layout, we've got a text widget which has some bolded text, and what that text is the D value. So at the top of this user interface, the date is shown to the user. And then we have an area labeled A, and what that's going to contain is, we'll understand this a little better when we look at the next line, but basically it's going to load that data file that we've created, and it's going to select from it whatever text, whatever events have been written down for the date. We also have on this user interface a button with the word save on it, and when that is clicked, we're saving to that file, that data file, the entire block of code that we have loaded from, that we've previously loaded, the L variable. And not just that, but we're inserting into that loaded block of data this reduced set of values. So we're going to insert into the previously loaded data block the date and the text which has been typed into the A area. And then we unview that user interface. So basically what this is doing is we're loading the value from the M file for the current date, allowing the user to edit it, and then saving those edited changes along with the date back into the M file. And this creates a history, a revision history that you could actually edit in the data and look at in the data if you needed to go back and get a previously edited version. It's a sort of simple way of creating a revision history. When you insert into this data block, you're putting the most recent version of the date and the events for that date into that block. We're not deleting any of the previous ones. Just when we do this select up here, what's happening is we're looking for the very first occurrence of that date. So those other dates and events, previous edit histories, are saved in the file. We just, every time we actually open up the editor, we're opening up the most current version and then saving back another newest current version. So that's nice. It creates a little edit history. The next thing here is a report. There's a file that I created here. It's basically in the exact same format that you download reports from PayPal. It's a CSV file, a comma separated value file, a standard format, and it just doesn't have any real information in it, but it's the same format. And so what we're going to do is we're going to read that in line format. We're going to read those lines, create a block of data values, which are the lines, and we're going to start looking at that, the second line in there. The first line is just headers, and then for each line in that block, we're going to do, so for each line in that comma separated value file, we're going to go through and do these things to each file, to each line. We're going to set a time value, and what we're going to do is pick out the second item in this parsed value. So we're going through that line and separating at the comma. And we're taking the second item that's all those things separated by commas, and we're converting that to a time value labeled as time. And then in this line we can do some conditional evaluations. If the time value is greater than midnight and less than noon, then we print the 8th item in those separated values, which we've labeled row above. And that in that data file is a bunch of money values. So we're going through every single thing in that data file, parsing each line, checking the times, and if the times are between a certain set of times, we're printing the money value on that line. Pretty simple. Okay, next we've got this little image effector, and Rebol has a number of these effects that you can apply. We just put a random list of them in here, so you can flip in any way you want. You can rotate by any degree, you can change the tint, you can change the contrast by any degree. We've just added a couple here. What we're doing is creating a layout, and in that layout we've got a text list with all these effects. And now what we're doing is, in the layout, the very first thing we do is load an image from this URL. Look at that, we've got an image there that's saved on a website. Load that, put it in the layout with the word image, and refer to it with the word pick. Then we have a text list with that, with a list of those effects. And then when an item in the text list is clicked, it does this. It changes the effect of the pick image to whatever value is selected from the text list and shows the picture. So little things like this are really simple to do in Rebol. You can see we've got quite a variety of different sorts of apps here. Very small. This is a total of about 50 lines of code, and for 9 apps. These are trivial apps, but I think the point that I'm hoping to demonstrate with these short examples is, they're all fairly short and simple apps. I've got some that are a little bit more involved, but these things, there's a huge variety in this list. And if you try to do this using any other system, even something that people think of as being, simple, try doing this in Python. Try and do this in live code. And not only will you end up with code that's much longer, but you also require much heavier tools. Now, live code has a fantastic and simple to learn language dialect, but you need to download, a program that installs to about 1 gigabyte on your system. And Rebol, all these things are included directly in a little 0.5 meg download. So, installing this and moving this to machines, any sort of applications you want to create with Rebol are just so fast. And Rebol has a built-in text editor. We don't need a heavy IDE. You have all the built-in help you need in Rebol, and everything you need to create the applications without any big heavy libraries, without any big heavy GUI builders or other tooling. The point of Rebol is to be able to do everything you need with very simple language. So the language is the solution instead of heavy tooling. That's a different approach than we see in most other ecosystems. And so this is just a really nice way to see how you can do very simple things, but these sorts of common things that you do, dealing with values, common dates and times and money values and things like that, and coordinates and things like that, and applying effects to images, or parsing strings of data, or creating little interfaces to allow people to work with data makes most of the common things that you do in any sort of program very easy to accomplish. And you see that the effect of this is exponentially apply it as you go to bigger and bigger applications. And it's very, very simple to create most of the types of applications that you're going to do. So Rebol is a great little tool for building not only simple apps, but apps that do the typical kinds of things that you do with computers. Let's look at this last one. I'm not going to run this. I'm going to run it, but we're not going to actually connect because we'd have to connect to a user and password here, and I don't want to put a user and password in this code right now. So this last little thing is a really useful little tool. It allows you to edit any file on an FTP server. So if you have a website and you want to edit the files, you can. We create a layout, and in that layout we've got two things. We've got a field and a text list. So up here is a field that's 600 pixels across, and in that field we're displaying an FTP URL, which includes the username and password of the site that we'd go to, and by default the public HTML folder. And when anyone enters an item, so by default you'd put your username and password here. When anyone edits that field, all of this code is run. And the first thing is an evaluation. If it's a directory that is entered into the field, if that value is a directory, then what we're going to do is set the data in the text list, the T data, to a sorted list of whatever is read from that URL. So when we click on that field and press enter, it's going to show us all of the files that are in that folder. If the text in that field is not a directory, then the built-in Rebol editor will open to the location of that file. The other thing that's in the user interface is a text list labeled T, 600 by 400, 600 pixels across by 400 pixels down, and whenever an item in the text list is clicked, the built-in Rebol will open up to the location of that text plus the value that was clicked. So basically it's going to open up the file in that folder, whatever file is clicked on, and let us edit it. Now the editor will, because we're putting in the username and password, the editor will allow us to edit the file, and that built-in editor in Rebol will let us save the file and the edited changes back to the website. So this is a fully functional website editor. You can put in your root folder or any other folder on your website and enter that folder, view all the items in the folder, and edit any of those items. It's a useful little program. There's maybe about six lines of code in there. So got a good variety of little apps here that you can learn how to create and learn how these things work, in a day. It doesn't take very long to learn how to do this sort of thing. And we've got a little game, we've got some CRUD type things, we've got some parsing type operations, or we've got some GUI layout type things, and these all do actually useful things. You can imagine taking these applications and doing something with them, making them more robust, and creating apps like that in Rebol is very simple. You download a little half meg interpreter, and you're off and running, and this thing starts up really quickly. You can open it right up, and it typically takes a fraction of a second for the interpreter to open, just like that. And I'm going to run these apps now. You can see. So here is our sliding tile game. Click on those boxes. And the point is to get these in the opposite order, from 1 to 8. Okay, now here's our to-do list. I'm going to type some text in here, sort of. I'm going to do some editing, and if I want to delete one, I can delete one. save that and open it later, I can load that back in, whatever the list is. So if I, for example, delete everything here, I want to load that back in, it loads the list I had before. And here's our, this says sliding tile game because the very first title in our program was sliding tile game, so it just keeps that same header. And this was our bar chart, generated bar chart. And here's our Madlib maker. Of course I can edit this to whatever I want. I'm doing this on a tablet, a little 7-inch tablet, so it's kind of, you can see what I'm typing, but it's kind of tough to type on screen. Okey-doke. Go. Here's our calculator now. Let's type in some numbers. Here's our calendar application. So I'm going to type in an event for January 17th. Brings up our calendar again. Put something else in for January 12th and just put that. So I go back to the 16th here. And of course, if I rerun this, this is actually saved to a file. So if I run this program now at a later date, it'll bring up all these same things. And so if I edit this, we'll save the changes. Put it back up when we've got the changes saved. Go back to the, let's see over here. Not sure what date I put that other thing on. Let's something here. Make sure I save it this time. Go back to the 18th, and we've got that. We can save those changes. Click on the close for this date selector, it ends the program. Oh, and unfortunately it's ended the entire program here, so let's just do this. I have to run the rest of this. Okay, so that's the downloaded PayPal report. If you look at the data at that link, you'll see that those are all values that for each line were between noon and midnight and noon. Okay, here's a little picture adjuster. Here is our FTP server editor, and again, I'm not going to put my username and password into the demo, but if I put that password in on my website and pressed enter, I'd get a list down the screen, and I'd be able to click on any item, and that would bring up the editor. I could edit that file and save it back to the website and actually edit the website. Okay, so I think that's enough of a demo to give you an idea how Rebol works, and just to see how things actually are done in Rebol. It's very, very simple to do most things that you need to in Rebol. These 9 applications are about 50 lines of code total, And even if you've never seen Rebol, it's easy enough to see how these things work. And there are a lot of fantastic systems out there. Rebol, I think, is suited best for doing a lot of the common types of development work that happen. It's clearly not suited, for building operating systems, at least in its current state, and building things like browsers. But I don't think that's what most users of computer systems need. We don't need systems like C or any of the other heavyweight development tools to do the most practical and productive things with computers. I think Rebol is suited to creating applications that are personalized. And for me, it's been a business development system. I wrote the Merchant's Village software, which if you look up on Google is one of the top consignment softwares on the web, and the absolute most commonly found result for open source consignment software. And that led to a very big business, and I've done it from Rock Factory, and I've had many clients over the years, big clients and small clients, that have been able to create fantastic solutions using Rebol. And the great thing about Rebol, because it's just so incredibly productive, is that you can do these solutions, create solutions quickly. I've created well over 100 programs for Rock Factory. We have programs that create chord charts for students, and that play chord progressions for students, and our entire scheduling system and our all of our business operations are completely managed by Rebol programs that typically took me a day or so to create, even the big ones, and that's valuable. Even if Rebol currently in its state, and we're waiting for Red to sort of become the new version of Rebol. As Red becomes mature, I'm sure everybody will move to it. But even in Rebol's current state, it's been out for nearly 2 decades, and the user interface is clearly old. And to me, that doesn't matter. To me, what matters is that it's just ridiculously productive. And after, I don't know how many years, but I started programming when I was 7. I'm 44 now, and after all those years of writing code, I studied computer science in school. I did a music degree, and I also studied computer science. And I did that back in 1990, and we were learning C and Lisp back then. And I saw all these changes. I had a big computer business, and I have some code that was written in the very first version of Visual Basic that's still in production in some businesses. The productive value of those systems, and the business value of those systems hasn't changed, despite all the technology changes. Those systems still run because they did something useful. And what I've found is with Rebol, I'm able to do very useful things very easily. And because the code is typically so short, we don't need an IDE to do most of the things. I write everything in pure text, and in a little text editor, very often in the built-in Rebol text editor. And I can go back and make changes to applications that I've written years ago, or create new features, because the code is so short and easy to understand. It's so light to work with. It's a real pleasure to work with Rebol. Unlike any other system that I've ever tried, and I've tried just about everything out there, and I have some other favorites, but Rebol continues to be my very favorite. The fact that it has the ability to to deal with common types of values, graphic coordinates and money values, and deal with those kinds of values appropriately, or IP addresses. You can add things to tuples very easily. We call tuples things like IP addresses or color values. You can divide a color in half. You can do things like that very simply. You can add coordinates. You can add and subtract dates. You can add and subtract times naturally, without any special formatting, without additional libraries. We have this great little user interface dialect that is fantastically concise, for for simple user interfaces. And we have other options. There's the Reb GUI dialect, which is great for most business type applications. The Merchants Village software was written with Reb GUI, but for creating a user interface to get data from a user, let them manipulate values is very, very simple in Rebel. Our Parse dialect, many people in the Rebel community use Rebel just because of Parse. Parse is absolutely dramatically powerful and unique in all of the development industry. People are used to using regex, and you get these things that are totally unreadable. And Parse is very readable, and it's very fast. It's faster performing than regex. And you can do all the same kinds of things that you can do with regular expressions. And the fact that all these things are built into the system into a little half-meg portable, cross-platform executable, and because they all just work together naturally, makes Rebel so easy to use. And it just scratches the surface. Rebel was designed really to allow developers to create dialects that do these common things. So we have a dialect for Parse. We have a dialect for creating user interfaces. We have all these other dialects, and there are a bunch of dialects that have been created. The Flash dialect was a great example early on, and there's a PDF dialect which I've used a bunch of times. And in fact, Red is created purely from Rebel code. So that, I think, in the end will stand to be the most dramatic example of the power of Rebel. But for now, even as it exists, Rebel is incredibly powerful and makes it so easy. We can write from write to and from URLs. We can do so many things. The protocols, network protocols are built in, and inside that half-meg interpreter. So many built-in features like that, and I think one of the real benefits and how Rebel is designed, it's hard for people to see this, is that we use the same functions to do just about everything. We read data from network ports. We use the draw dialect, uses the same series functions. You can add and manipulate a draw dialect block of draw code using the same functions that you use to manipulate strings, and the same functions you use if you want to deal with a file system, or the same functions you use to insert and get items from a network port. The fact that we use these intimately familiar same functions for everything in Rebel, for manipulating strings and data from any source, and in fact for manipulating code and doing metaprogramming, makes it just so natural to do just about everything we need to do in Rebel, because everything works the same way and is composed. And I think that's the most powerful idea here, that data is composed, or not data, but code is composed very naturally in Rebel, much more naturally than you'll see in other, in really any other development system that I've ever come across. The way you compose the basic features and the basic things that you do when you write just about any kind of program, it fits together really nicely and neatly in Rebel, and productively. More than anything, productively. You have all these basic features which seem very simple, but they get used over and over and over and over again. And Rebel provides all the basics in very simple ways that go together naturally. All these things are built into the fabric of the Rebel language to make it super simple to use. So these little examples kind of give you a taste, but that simplicity continues on into the most complex applications. So simple things are simple, and complex things stay really dramatically simple, much simpler than I've ever seen in other languages. So hopefully that gives you a good idea of how this all works. So we can end this here.